Okay, to start this video out, I wanted to kind of show you here. I put these just on the desktop. These were the two things that we had captured from the oscilloscope. And you can see here, this is just the bitmap, and it's literally just an image of this. I'm trying to get this to, well, it's not zooming in very much. There we go. And so you could insert this into a Word document. Now, the problem with this particular oscilloscope is, of course, that, you know, if you were to print this out, one, you'd want a color printer, and number two, this would be horrible to print because it is basically using a ton of ink or toner because you've got all this black that it's going to print on. And that's a typical problem with oscilloscopes. Now, there might be a setting, I haven't looked too carefully on the scopes that you will use when you come for an immersion weekend. We have what's called an ink saver mode, which basically, before it does a screen capture, it kind of inverts the color so it makes the background white. Now, the reason the background's not typically white is that's pretty harsh on your eyes and on the screen when you're trying to just, you know, sit there and stare at it for long periods of time. So this isn't something, you know, as far as turning in electronically, like for your reports, this would be a fine image to turn in electronically. But as far as wanting to, you know, do something that you would be, you know, printing out, that wouldn't necessarily be the best thing. Now, the CSV file, which some of you might be already familiar with, stands for something that's called Comet Separated File, and it's something you can open up in Excel. And basically, you've got time here and then volts, and what you could literally do here is, well, here, let me just do it this way. I don't plot in Excel very much at all, so I'm just going to delete these two. Oh, maybe. Sometimes my touch keyboard annoys the crap out of me. So I'm going to just delete those two rules here, and then select these two columns, and then, of course, insert you know, line or area chart here, so, or scatter. So we could do a scatter plot here, for instance, and I'll just do a scatter plot with smooth lines here, and you can see right there. I mean, obviously you'd want to adjust the settings, but oh, now we've got a nice image. And what I mean by adjust the settings, you know, like adjust how these labels are and things of that nature. So, and you could do that by also adjusting how they're being displayed here as well, because these are being displayed in scientific notation. But we can clearly see here, it's like, oh, I've got a nice little chart here now that's going to have a white background as opposed to a black background. So obviously you can use any kind of plotting tool. I actually typically, when I'm making graphs, use a software package called MATLAB, but that's fairly advanced engineering software, which is really not designed as a plotting software. It's just something it can do. It's really designed for other things. All right, but let's get back to the oscilloscope and look at then the audio generator slash function generator. So this is not really what I'd consider a function generator because it can only generate a square wave or a sine wave, which is controlled by this. And you don't really have a full range of frequencies that you can select. And you also have a limited on the number of the amplitudes. But for the courses that we're going to do here, this will be adequate. A full-scale function generator is actually about the size of the oscilloscope here. And you can generate all sorts of types of signals. You can even generate like FM and AM signals on it. Things of that nature, which again, when you come for an immersion weekend, you'll get to use some of that equipment as well. But it behaves very similarly to this little audio generator that we're using. So I'll go ahead and turn the scope back on. And I've just went ahead and plugged in my yellow slash pink probe here. And I just want to go ahead and show you here that I will go ahead and make sure channel 1's on here, but you can see I turned it back on and it saved the fact that this is a 10x probe. The only thing you want to make sure though is that this little slide here is sometimes easier to move than you might think. So if something's not looking right on your reading, the first thing I would do is make sure that your probe is also in the 10x mode. Because if these things aren't matched, if the probe and this number here aren't matched, it's not going to give you a correct reading. All right, so now let's go ahead and just look at this here. So let's look this. First off, you can see here the sync we're not going to be using here. This attenuation is if we want to make a really low voltage signal, which we're not going to want to do. So we're going to always leave this at 0. The waveform here gives us two options, either a sine wave or a square wave. We're probably going to be using the sine wave more frequently than not. And then up here, the frequency range in hertz times 1 or times 100, which kind of is self-explanatory. And then you can set this knob here. Now be careful to do, make sure you do what I failed to do last time, is if you have it set like this, and actually I'm already at it here, I have low battery here because I forgot to turn this off. If you don't turn it off, it's just going to sit there and constantly put out that signal. So hopefully I'll be okay, otherwise I'll have to pause the video and go grab a battery here. Alright, so I'll keep it off for a second. And then I've just got these, and I'm going to just, at this point, just look at the signal here. I'm not going to actually do anything more than just look at the signal and take some measurements. So I'm attaching the grounds to the ground, and then I'm just going to, clip that into there just like that. And then what I'm going to do here is it's set at a sine wave. I'm going to first off turn the amplitude down pretty good, which is turning it all the way to the left. And then I'll turn it a tiny bit back to the right. And so then I will put on the 1.5K. Now, nothing's showing up on my screen right now. That doesn't necessarily mean that my battery's dead, because remember, sometimes we want to just start off by trying to hit the auto scale here. And it does look like my battery might actually be dead. Yeah, so let me pause my video here. Okay, I am back, and magically when I put in a new battery, there's something that displays on it. Now, I'm going to redo the auto here because it's not going to have done a good capture on it, because it was trying to do single signal, and it's still not doing it. Let me see if I just turn up my amplitude a little bit. It says band limit is on. Oh, turn my band limit off. Yours is probably set at being off there. Well, this just will give us a good way to actually see how to set up the signal so that we can get a nice clean picture when we get something that's not as nice to start with here. So all right, so let me kind of go through what I did here to this. So we have this here, and we can definitely see the sine wave coming in here. And these probes here are pretty, and you might say this is pretty noisy, and it is, but these things can be pretty sensitive as far as, having connections and everything. So let's go back through precisely what I did here. So I try to do the auto set. And it says band limits on, and I don't get this nice thing, and you can see it's what's going is it's kind of bouncing around here. Now if I just do like a single one here, if I do this run stop, this is taking a single measurement, and you can see it's okay. It's not great, but it's okay. But if I let it run again, it's going to go back to this. Now the way you can try and fix this is with your trigger menu here. Now there is something that's you can try and just what's called adjust the level here, And adjusting the level is basically what voltage it uses to trigger off of. And triggering is like basically when does it start taking a measurement. And so if I go into the menu here, there's several different types of triggering modes. There's edge trigger, there's pulse trigger, there's slope, video, and then there's even alternate. Now, edge trigger means it's literally looking for the edge of a signal in order to trigger. So I'm going to select the edge triggering. Now the problem is you can already see here, this is kind of bouncing up and down because of noise that we're getting on the signal here. And because it's bouncing up and down like that, it's having a difficult time, because what happened is if I have, for instance, my level set right here, it's going to trigger twice, because it's going to say, hey, look, I bounced up and then went back down, and then I bounced up again, so it's going to trigger it twice. So it's going to be taking two readings, and that's why we get this kind of shadowing, kind of ghosting effect going on here, is that there's like basically two readings getting taken at the same time. So one thing to try and change that is to doing edge triggering, you can try and say, okay, well, let's do, slope. I've not personally had very much success with that, so I'm going to put it back to edge triggering. But then it's in the auto mode for setup, and this is where we want to manually set things up. So there is this hold off, there's a sensitivity, and there's this coupling. Well, coupling means it's looking at DC right now, is what's called DC coupling, which is fine. But basically, what you can do is you can also do something that's called high frequency reject. And the reason that what this is doing is basically what you're telling it now to do is, hey, if there's any high frequency signal going on in there where it's like bumping up and down, because that's what's going on here, is bumping up and down quite a bit, just reject that. Ignore that for now. I don't care about it. And so what it's doing now is it's getting just a single trigger. So if you're having problems with it triggering, yours might not have the issues that mine had, because the first time I did this, when I was getting ready to do this video, I didn't have any problems, and then of course I put a new battery in, and I have problems now with it. But you can also, I'm putting it back in the DC for instance, you can also just do a single measurement here, just do a single capture here. So I'm going to go ahead though and go back and put this in the high frequency reject here. And again, you could still do it as a single measurement. But then what I'm going to do here is I'm going to show you a couple other things here as far as taking measurements go. So we've got the signal being captured. Now first off, if I adjust, actually it could be just because of the voltage being too low. If I adjust the amplitude here, you can see here, actually let's just do another auto trigger. Yeah, it was because my amplitude was too low. But if I do another thing here, we can see when I adjust the amplitude, of course, I adjust this, and you can see when you get it, see, I'm getting that triggering issue again because my amplitude is just too low. And when you have a low, basically what it's saying is this can put out low amplitude signals, but it's really noisy data. And so if I turn this up a little bit here, we can see this here. Now I've already got some things already measured here. I don't know if those will be on yours, for instance, so I'm going to clear everything off here. So we have this set up here. So now we've got our signal, and this is the types of signals we'll be looking at. And we want to take measurements. We want to know what the frequency of the signal is, what's the maximum voltage, what's the minimum voltage. So there's several ways to do this. One is you can turn your cursors on. And you can do manual, but I like to do the track, which means it tracks on the curve. Okay, so, and I can say, okay, cursor A, and I'm going to put it like right here, and then cursor B, where is it tracking? Here it is. And so I could put it right there, and then you can switch back through this. And now you can see here that the delta Y, meaning the peak to peak voltage, sometimes they call it the amplitude, but mathematically that's technically incorrect, is roughly like 3.2 volts. Now, if I wanted to know, for instance, what the frequency is, well, then I would want to set my cursor such that frequency would be as the pattern starts repeating. So here's my low, and here's my low here. And I can see then it puts this it does all these calculations. Delta x, that's the change in time between these 2 points. So the change in time between those 2 points is 664 microseconds. And you can see that, oh, well, the change in the y value is 0 volts because, well, you're at the bottom of both of those. And then it does 1 over delta x, which gets you your frequency, which is 1.51 kilohertz, which is what we should expect because this is set at 1.5 kilohertz. Now, that's using cursors, which cursors are great. And then basically you just keep pushing in, you push in to, and then you just get to move these cursors around and around, and it will show you which one you're currently being moved on, and then it just does these computations for you automatically, which is kind of nice. But cursors I often don't necessarily use because we also have other things. There's this button here called measure. Well, as you can guess, it will measure things for us. And there's different things. We can measure stuff with voltage and we can measure stuff with time. So if I hit time here, you can see it says, well, hey, I can measure the period or I can measure the frequency. So I'm going to measure the period, whoops, time. And you have to use this dial to select which one, and then you hit enter again. So I'm going to measure the period. And then that's where it puts it down here. Now the nice thing about this is that that period will always be present no matter what we do to the signal. For instance, I'm going to change that frequency now. I just changed my function generator down to 1.2 kilohertz, and so the period changed with it already. So I'm going to change it back up here. And you can add other measurements here. You don't have to just put one measurement. You can say, okay, well, I also want the frequency as well. And let me turn these cursors off. Oops, I took the measurements away. So let me put them back here. Period. Frequency. And so you can see that this is now 1.06 or 1.15 kilohertz. Now this is going to be a more accurate way of measuring the frequency than using the cursors by hand. And the reason is this oscilloscope is doing some kind of averaging to make sure that it's not literally just taking one measurement to determine what the frequency is. So this is going to be a more accurate way of determining the frequency. But then again, what I can do is I'm just going to switch this down to 1.2 kilohertz, and you can see the measurements automatically update. And I can even switch it down to 1 kilohertz. Now if I switch it down too much, I might not be able to yeah, you see, now it's saying the period and the frequency it doesn't know. And that's because what's currently on the screen, I've got it set at 320 hertz as a side note. What is currently being shown on the screen isn't one full period of the signal. So it can't measure the period or frequency because it's saying, hey, there's no repetition going on. So this is where you can either auto scale it, but I just did an adjustment on the scale manually right there, and suddenly the period and the frequency shows back up again because now it's got a full period. So it's actually looking at all these data points, but it's saying, well, wait a minute. Here, you don't have enough data points here to show me that there's a period. This signal that you're showing me right now has no period. Okay? And so let me go back to the 1.5 kilohertz, and let me, okay, so we got 1.5 here. And so those are some of the measurements you can take as far as the time. Taking a sip of coffee there, sorry. Now the other thing I want to show you here before we move on to the voltage measurements is this on your here, you have this times 100, which of course just means that you multiply everything by 100. So instead of this being 1.5 kilohertz, this would be 150 kilohertz. And now it's saying the frequency right now is 25 kilohertz, because at this point you can see what we've got is it's bouncing up and down too fast. So we could auto scale, or I'm just going to again adjust it manually. And now we can see here, well, it's not right at 150 kilohertz, but we're at 147 kilohertz. Okay, so I'm going to adjust it back down and put it back down on the one there. All right, so let's look at some other measurements. And let's look at some voltages here. Now you can do, V max, V peak to peak. And then this is where, as I said, the V amplitude isn't actually correct on here. It's actually doing an amplitude as it's not doing it from a ground reference. It's actually doing a peak to peak of the signal. But let's go ahead and just do V peak to peak here. And you have to hit the menu button because now it's over here. So V peak to peak is 3.28, which we did determine that just using our cursors manually. Other things we can see here would be voltage. Like we could say, well, what's the maximum voltage? And now what you can see is it's starting to push off to the side measurements that we've already taken here. So you can't have just any number of measurements being displayed. You can only really have 3 being displayed at a time. But obviously, if you want to take multiple measurements, you just keep going through them and displaying the ones you want. The other thing you can do, but it gets a little, you lose the signal here. As you can see here, you can display all of the measurements here. I'll clear the ones here. So you can display all. Whoops, I keep hitting the wrong one here. And what you can sometimes do is move your signal so that you can see all of the measurements at one time here. And basically you could do a screen capture of this, export this. Now there's definitely things in here that are things we're not going to be concerned about, like the rise time and fall time isn't something we're concerned about currently. That's something that we'll be interested in future courses. RMS value is not something we're currently interested in. Although again, that's something we'll be interested in future courses. Right now, primarily what we're going to be looking at is things like period, frequency, and the maximum and minimum voltages, things of that nature. All right, so that kind of gives you a quick overview of what this does. There is one other thing that you can do here with this, which we won't really do this very much, but I'll go ahead and show this to you just as an interesting kind of aside of something that can be done here. So first I'm going to hit the off button by accident. I'm going to hook up the sync signal here. On channel 2 here. Whoops. Sorry, just getting some settings adjusted here. There we go. And sometimes when you have 2 signals going and the types of signals you're going, you can't get them both captured at the same time, meaning that both having them trigger precisely at the same time. And that's because you have a nice smooth sine wave here, and then you've got something that's a square wave, and sometimes it's difficult to get those both to trigger so that you get a pretty one all the time. What you can do is you can try and do an auto set on it. Doesn't always work because it's we're having the same issue we had before. But what I wanted to show you here is there's this math button, which is kind of interesting. There's different operations you can perform here. So you can do, for instance, A plus B. And see what you would get from that. And you could also do A times B. And this is it's a little hard to see this right now on this, but then you can also do what's something which we will look at later on, which is called an FFT. And I want to point out the FFT right now here, because this is actually something, without knowing all the details about what it is, it's something called a fast Fourier transform. And you can see something right down here. There's a little peak right here. If we were to actually measure what this peak is here, this is actually at 1.5 kilohertz, because this is saying what frequencies are present in the signal. And it's saying basically, well, you've got a 1.5 kilohertz frequency present. Now, if I do this times 100 and then do a run stop on this again and change my here, let me turn the math off. Let me turn channel 2 off too. I don't want that on anymore. Channel 1. And do an FFT on this. You can see that there's a hump now that's further down. And this is actually going to be more around at 150 kilohertz. So it's trying to show you what frequencies are present in the signal. And you can actually, based off of what frequencies are present, there's a lot of useful information you can obtain from a signal. Like you can determine what kind of signal it is, even just looking at it, at what the frequency spectrum is. Or sometimes you can even determine if something's about to break. A motor, for instance, you can sometimes determine if a motor is about to break based off of what frequencies are present. So that's something that we won't play a lot with in this course, but I always like to point it out. It's a very useful feature that is often used in industry a lot, is looking at the FFTs of them. All right, so that's going to wrap it up for the basics on here on how to use the oscilloscopes. Now we've just really kind of touched the surface, getting you enough to kind of play around with them. You can't, as long as you make sure to connect the grounds up correctly, you can kind of play with this with a circuit, take different measurements, you know, play with your audio generator, and you won't have to worry about damaging anything. Just make sure you connect your grounds up to ground, because you never want to short your power to your oscilloscope, because you can not just damage it but turn it off. And then make sure to do what I failed to do, which is when you're done, turn this off, because if it's not turned off, you'll basically kill the battery. It does not have an auto shut off feature like the multimeters do.